Hi, everyone. Welcome once again to this channel. And we welcome you once again to our series on strength of materials or mechanics of deformable bodies. Kindly subscribe, like, share, and leave your comments and suggestions at the comment section. We are glad to have you once again with us. And today we are looking at normal stresses. Normal stresses. Let's quickly run through for our lecture, which is our second lecture. Normal stresses. Good. Now, forces, anytime we have a body or a bar, for instance, what we have on our screen, we have the longitudinal side. This is the longitudinal axis of the bar, the longitudinal axis. And then we also have the transverse axis or the transverse section of the bar. Good. Forces which are applied at the longitudinal axis of the bar are referred to as axial forces. Forces which are applied at this longitudinal section are what we refer to as axial forces. Now, axial forces acting on a bar or member act in two ways. They act in either in tension or in compression. Now, when axial forces are acting in tension, then it means that we have our diagram like this. They are acting in the longitudinal section. So in tension, we have our loads or our forces like that. So anytime we have this kind of loading, we say that the forces are in tension. They are in tension. And then when we have our loading in this form, then we can say that our loading is in compression. It's in compression. Good. These are the two ways in which axial forces act on a bar or a member. Having said that, let us consider a bar which is in tension under the action of loads. If I have my bar like this and I have loads at the longitudinal section, so I have a force of P, a load here, and another force P here. Now, this bar is in tension because the forces are pulling the member or the bar. If I decide to cut through a section like this, this is A, this is A. If I cut through this section, which is crossing the longitudinal section, it means that I am going to get two halves of that member. And this other half will also be like that because I've cut through the section which is AA, and the load is here, the load is here. Now, this load on this member here, or this force on this member, is going to be distributed uniformly at the cut section here. Therefore, at this section, I'm going to get the load equally distributed. The load equally distributed at that session, and the load equally distributed at this session also. Take note that always this distribution here will be opposite in direction to what is at this side. That is why you are seeing that the distribution here is also opposite to the load at this end. Now, this distribution here is as a result of the load which is applied at this section. And don't forget that this load is perpendicular to this cross section, perpendicular to this cross section. And in the same way, this uniform distribution here, which is also representing the loads, are perpendicular to the cross section here. When we measure the intensity of these distributions at this end here, then that is what gives us what we call stress. So the intensity of the forces here, the intensity of these forces which are uniformly distributed here is what we refer to as stress. Stress. Therefore, we can say that stress is the force per unit area. Don't forget that this area should be perpendicular to the application, the point of application, or the force which is applied. It should be perpendicular. So from here, we can say that because stress is the force per unit area, we can say that the formula for stress, sigma, will be equal to the applied load over the perpendicular, the area perpendicular to the applied force, which is A. And this is the formula for stress. This P here is the load or the force, and the unit is in newtons. And this is the area, and the unit is meter squared. And therefore, this is the cross-sectional area. Don't forget that, the cross-sectional area. And from there, we can say that the unit for stress is Newton per meter squared, which can also be referred to as Pascal. It can also be referred to as Pascal. Good. Now, when this stress, if this stress is produced by loadings which are tensional, then the stress is given a positive value. Therefore, we can say that tensional stresses are positive, whereas compressive stresses are negative. Take note of that. So you can see that tensional stresses are positive. Tensional stresses positive, whereas compressional or compressive stresses are negative. Now, we assume that the stress distribution here is uniform, but take note that we can only get a uniform distribution of the stress, uniform distribution of the stress only when the loads or the forces are applied at the centroid, or passes through when the loose passes through the centroid of the member or the bar of the member. If the loads are not passing through the centroid of the member, then the distribution is not going to be uniform as we have here. For example, if I have, a body like this, and I apply tensional forces in this direction. Now you can see that these forces, the centroid might be somewhere here in the body. This will be the centroid or the center of gravity. Therefore, you can see that these forces are not passing through the centroid. And for that matter, the distribution of the stresses is not going to be uniform. Other units for the stress can be kilopascal, which means that we have 10 raised to the power 3 Pascal, or we can also get megapascal, which will be 10 raised to the power 6 Pascal, and then we can also get gigapascal, which means that we have 10 raised to the power 9 Pascal. And this brings us to the end of our lecture on stresses. Don't forget that stress is the force per unit area. And we are saying that this stress is called the normal stress because the load is normal or perpendicular to the area. And so we refer to it as the normal stress or the direct stress because the load is perpendicular to the cross section of the bar. This brings us to the end of our lecture. If you have any contribution, any suggestion, any comment, or if there is anything you don't understand, you can let us know at the comment section, and we will be glad to take you through or to clear your doubt on this area. Once again, we want to thank you very much for watching and staying with us up to this point. Kindly subscribe, like, share, and hit the notification bell. We'll meet again in our next lecture. Up to that point, we want to say bye-bye for now.